Okay, so far we have been able to do with radicals questions like these. So let's take a look and just kind of rehash what we've done so far. Let's start with the square root of 147. So how do we simplify this? Well, we need to split the 147 up, and right now I have no idea how to do that. So let's kind of go to our calculator. I already have 147 typed in. I'm going to start by dividing by 2. And that's not going to work out. So what am I looking for when I do this? Well, I'm looking for perfect squares. So I'm going to divide by 3. 49. 49 is a perfect square. So I can rewrite this 147 as 3 times 49. And the square root of 49 is 7. So I have 7, and then the 3 stays in here. So we're done. Let's come up to this one. So the 50, hopefully you've done enough of these that you're getting somewhat familiar. I can split up that 50 to 2 times 25. 25 is a perfect square. And the x to the 5th, I need to split up to x to the 4th, x. Always go with the largest. So if I start at 5, count down to split it up. And the y to the 12th is fine. So now I see that I can do this square root, and this square root, and this square root, which leaves me with, on the inside, 2x. The square root of 25 is 5, but notice I have a 2 out here. So square root of 25 is 5. 5 times 2 is 10, so I have a 10. The square root of x to the 4th is x squared. I just divided my exponent by 2. And the square root of y to the 12th is y to the 6th. So we're good on that one. This one I have a multiplication, and remember we multiply the numbers in front and the numbers on the inside. So I'm going to get 12 root 18. Now, don't stop, right? That's going to be the trick. We need to keep on simplifying if possible. And it is possible to simplify that 18 down. If I divide 18 by 2, I get 9. And 9 is a perfect square. So the square root of 9 is 3. So I did that square root, which leaves a 2 on the inside. 12 times 3 is 36. And I have a root 2. So that's so far. But what if I had something like this? 5 root 3 plus 2 root 7. And so far, I've said, well, we can't do that. And that's true, we can't do that. But the question is, well, why can't we do that? So let's take a look and let's explore that possibility. So here I've set up a few examples, and these ones on the left, don't bother writing down, just pay attention. What is 2x plus 5x? Well, hopefully you said 7x. And please tell me you did not say 7x squared. We do not add our exponents. If I did 2x times 5x, if I was multiplying, then I get 10x squared. But if I'm just adding, I'm not going to do that. So just 7x. What about here? What's 3x plus 5y? Please tell me you did not say 8xy. No. Can I do this? No. Do I write no solution? No. Well, what is this? That. I can't do anything to it. So I just box it. That's done. So what about this one? Now, why couldn't I do these? Because they were not like terms. Whereas up here, these are like terms. So as I come down to this third one, I see that the 2x and the 3x are like terms. So 2x plus 3x is 5x. Well, what about this plus 5y? Just copy that down. And I'm done. All right, so now actually write down these examples over here that are on the right. So these two are like. They are like radicals. So I can add them. I have, basically I'm saying I have root 3 plus root 3 twice. Now plus root 3 5 times. Now hopefully you're seeing a shortcut, right? 2 plus 5, 7. I have 7 root 3s. Or if I write it out like this, 7 of them. So 7 root 3. Notice it's not like squared or anything like that. Just like over here. No, not squaring the x. So what about the second one? Well, these, the root 5 and the root 2, those are not like. So what do? I'm done. Can't add them. Now, the same rule applies for subtraction. If I were subtracting up here, it'd work out. In fact, we'll do one like that. So what about down here? What's like? Well, this is like this. So it's 2 root 3 plus 3 root 3. 5 root 3. Then plus 5 root 2. This thing that I couldn't do. So hopefully you're seeing that adding them so far not that hard, but we are going to have a few tricks that we're going to have to do. Alright, here's 4 examples, and they're all pretty easy. These are like, so I can add them, and I get 9 root 5. These are like, I can add them. So what do I get? 13 root 3. Now what's the number in front here if it's not written? Did you say 0? Did you say 1? It's a 1. 1 times the 7. So it's root 7 minus 6 root 7. 1 minus 6 is negative 5. So negative 5 root 7. Right here, 10 root 2 minus 6 root 2. That's 4 root 2. Now let's get tricky. As I look at this first one, I'm tempted to say I can't do it, that they're not like, but I need to simplify first. And I can simplify that root 20. So far the examples I gave, you couldn't simplify them. But now I could simplify. So how could I split up that 20? And can I do the square root of 4? Yes. I'm showing a little bit of an extra step here. So I did the square root of 4 and got a 2. So I have 2 times 2. And now these are like terms. They're both root 5s. I get 8 root 5. I can check to see if I did it right in my calculator. And here's how I do that. I type all of this in, and my calculator will give me a decimal. Then I take my answer and type all of my answer in and see if I get the same decimal. If I do, then I have done it right. If I do not, then I made a mistake. All right, let's try this one over here with the root 12 and the root 3. Again, I'm tempted to say I can't do this, but actually I can. I need to simplify the root 12. 4 times 3 will work out fine. I can do the square root of 4. The square root of 4 is 2. Now 2 root 3 minus root 3 is root 3. And I'm done. Again, how do I check this? I type all of this in my calculator, get a decimal, and I type this in my calculator, get a decimal, and I see if those produce the same decimal. And if they do, I did it correct. All right, so I have a bunch of stuff here. So let's break down the 18. 2 times 9. 9 is the perfect square that is in 18. Now, we might be tempted on this 32 to say 8 times 4, but I always want the largest one. So the way I do this is I do 32 divide 2 first. I get 16. 16 is a perfect square. Now, if this wasn't a perfect square, I'd move on to 32 divide 3, then 32 divide 4, and so on until I got a perfect square. I got a perfect square right away, so I have 2 times 16. 72, again, I'm tempted to think 8 times 9, and 9 is a perfect square, but that's not the largest. I always start at the largest. So if I do 72 divide 2, I get 36, and 36 is indeed a perfect square. So I'm going to use that. So I get 2 times 36. So I have to simplify all of these, is what I'm getting at. So simplify before you decide that you can't add. I can do the square root of 9 right here, the square root of 16 right here, and the square root of 36 right here. Square root of 9 is 3. And 3 times 2 is 6, so I have 6 root 2. Plus, square root of 16 is 4, and 4 times 3 is 12, so I have 12 root 2. And then here, square root of 36 is 6. I don't have a number out here, so 6 root 2. And now I see these are all like terms. So that means I can add them. And 6 plus 12 plus 6 is 24 root 2. Hopefully you're not getting too tripped up here. So now I'm going to throw some multiplication into the mix as well. And we've done most of the multiplication already. So this first one, I multiply the numbers in front, get 14. Multiply the numbers on the inside, get 12. Now I need to simplify that. Simplify that root 12 if possible. That root 12 changes to 4 times 3. And the square root of 4 is 2. So 14 times 2 is 28, root 3. Let's try this one over here on the right. Again, I multiply the numbers in front. 9 times 11, 99. Now, I'm going to note right here that 15 is divisible by 3. 3 times 5. Just to make it easier here in a second. So if I do 5 times 15, I get 75. So 75 is on the inside. I wanted to note this 3 times 5 because that gives me a clue that down here I can do 75 divide 3. That gives me 25. So 3 times 25. Why did I do that? Because I'm finding that perfect square to simplify. So I can simplify this 25. Square root of 25 is 5. Now I have a 99 out here. So 99 times 5. I get 495. So I have 495. What's left in the square root? 3. Remember, when you do a square root, it comes out. All right, how about this one? What am I going to have to do? Well, distribute this whole group to every term. So I get 12 root 6 plus 18 root 4. Now this root 6, I'm not going to be able to simplify. This root 4 I can. It's 2. Square root of 4 is 2. So I get 36, because 18 times 2, plus the 12 root 6. How about the second one? I could distribute this into both of those. I get 15 root 6. Notice this one doesn't have a number written here. It's not written. That's a 1. So 5 times 1, 5. 3 times 3, root 9. I can do the square root of 9. I get 3. So I'm going to have a minus 15 right there. And I have 15 root 6. All right, just a few more problems to clean it up, and you'll be done. How do I simplify? So I'm adding all three of these. So what do? Split them up. First, simplify. 8 is 4 times 2. Copy down my plus. 12 can become 4 times 3. Yes, I know, 6 times 2, but those are not perfect squares. Plus 18, 2 times 9. Again, yeah, I know, 3 times 6, but again, those are not perfect squares. I need the perfect square to simplify. And not everything simplifies, so don't spend 20 minutes on something that doesn't simplify. So we have the 4, the 9, simplify. So we get 2 root 2, because the square root of 4 is 2. This 2 stays on the inside. Plus square root of 4 is 2. Plus 3 root 2. These are like. So I have 5 root 2 plus 2 root 3. Done. Oh boy, the big kahunas. Let's do the one on top. So before I do that, it's like if I had this. X plus 3 times 2x minus 5. Something like that. I would do this times both of those. That's 2x squared minus 5x. 6x minus 15. And then I'd combine whatever's possible. Now, in the case like this, it's always the middle things that combine, but with radicals, that's not necessarily going to be true. So let's see what happens. I do this multiplication, I get 5 root 20. Then I do this multiplication, I'm going to get plus 5 root 12. Now I do the minus, take this minus with it, so minus root 30 minus root 18. I simplify if possible. I don't stop. So the root 20 becomes 4 times 5. The root 12 becomes 4 times 3. This 30, we could spend some time on it, like 2 times 15, 3 times 10, and so on. But ultimately, no combination is a perfect square. So the root 30 stays. And 18 is 2 times 9. The square root of 4 is 2. So I get 10 root 5. This square root of 4 is 2, so I'm going to get 2 times 5, so 10 root 3. So could I combine those? Nope. They're not like terms. Minus root 30. And then I can do the square root 9. And I have a 3 root 2. So of that, none of those are like. So none of them combine, and I'm done. And yes, I had to do all that, just in case it would simplify. This one I'll distribute. So I get 6 root. Now I'm going to want to note this 14 is 2 times 7, right? So 14 times the 7 that I'm multiplying by, I get 98. Plus, now there's no radical here on this one, so 3 times 3 is 9, root 7, that root 7 stays, plus, now I'm doing the 4, there's no radical on the 4, so I'm just going to get 8 root 14, then on the last one, plus 12. So this simplifies, and I'm going to type in the calculator 98 divide 2, I'm taking a hint from up here, because that 14 is 2 times 7, my calculator will say 49. So I can split it up to 2 times 49 plus 9 root 7, 8 root 14 plus 12. Don't be skipping out on steps. The square root of 14 is 7. So 7 times 6 is 42. 9 root 7, 8 root 14 plus 12. None of these are like, so none of them combine. But sometimes they are like, so just be watching out for that.